Today we're going to use the calculator instead of the quadratic formula to find the zeros of a function. And it does mean we're going to have to look at changing the window a little bit. First question, let's see, we've got a actual quadratic. They gave it to you, yay. If you want to know how high the rock will go, well, oh, that's the vertex. So this part doesn't need the calculator, and it will tell us some things that we need to know about setting up the window. The max height is at the vertex. Okay, so that value will be negative b over 2a, will be the time when that hits. And then we plug in to figure out what the actual height is. So let's see. We have negative b over 2a, negative 50 over 2 times negative 2.7. Calculator says that is 9.259. How do we find the actual height? That's the time. We need to actually trace at that time in order to figure it out, or plug it in by hand. I think it's going to be easier to trace, so let's just go ahead and use the calculator. I'm going to plug in. We have to use y1 is negative 2.7x squared plus 50x plus 6. The calculator is stupid, so we have to use x's instead of t's. I'm going to just type that in under y1. Okay, and then when I graph it, I don't see much of anything. It's a very steep thing crossing near the y-axis itself. I can trace this particular problem. I can trace for the problem sets. I'm going to have to reset the window before I even can trace. But if I trace at 9 point, I would like to use some extra accuracy. In fact, I'm going to trace at negative 50 divided by parentheses 2 times negative 2.7. I'm just going to trace there. Oh, look, you can actually type things in when you trace. Hit enter, and it says it's let's write this down. If it gives you an error when you trace, you have to reset your window before you even trace. It won't trace at a number that's not inside the window. You have to put parentheses around the bottom, otherwise it doesn't divide by both 2 and negative 2.7. And you get 237.5 feet up. That's how high it goes. So we're going to reset the window so we can actually see things better. Go to Window. I'm going to make X max big enough that I can see things come down. So usually about 2.5 times what the vertex number is will work. So 2.5 times 9 is about 25. So I'm going to make X max 25 in this problem. I'm going to make my Y max big enough that I can see the top, 237. So I think I'll make the Y max 250. When I graph it then, I see the actual parabola. Okay, and if I trace it 9.259 now, I can actually see it blinking on the top. Hit the ground is when the height equals 0. We're going to do what's called calc zeros. So
That's an or.
Oh, why did I use H? Well, M is good. I think they used M for moon. Okay, so H equals 0. The height is 0 over here. And also, if you do the quadratic formula, you actually get two answers. We don't want that first answer. That would be a little bit before we started throwing the rock. So we go second calc zeros, and zeros, it isn't the numbers there, it's zero, just possibility 2. You can either go down to it or just hit the number 2. Okay, it says left bound. I need to bring my cursor just to the left of the number I want. And then right bound, I need to get beyond it. You can't see it anymore, but it doesn't matter. And then my guess, I'm going to back up a little bit. There we go. And it says 0. Says x equals 18.637751, whatever. And that's seconds. So it takes about 18 seconds for it to hit the ground. Now, in order to check the thing with the Earth, I'm going to go to y equals, and without erasing the first one, I'm going to type the second one in as y2 at the same time. Okay, and I graph it, and the picture that I see is, this was the moon, and boop, mine is coloring it, the original one in blue and the new one in red, but, well, does it hit the ground in less time on the Earth? Yeah, it's much less time. So,
Why? Because gravity is stronger on the Earth, because the Earth is bigger.
okay. There is one other thing that the problem set does, and we'll look at it in class when I'm trying to hit a particular height. If you might want to try this. If I want to hit a height of, for instance, 100 feet high, I can graph y3 equal to that height, and then do second calc intersect to try and find the time. You can try it yourself if you want. We'll go over it in class. All right. X-intercepts for this second problem. X-intercepts give the factors. So an x-intercept of 3 is matched with the factor x minus 3. Remember, it's opposite inside the parentheses. So if I write up the two factors, I have x minus 3, x plus 1. Now, that isn't quite right, because remember, these things have an extra thing that we don't know, just like with the vertex. We might be taller or wider, so we have to figure out what the leading coefficient A is also. And just like with the vertex, we use the extra point, 4 comma negative 10, to figure out what A is. And again, 4 goes in with the x's, x is 4, and then negative 10 is the y coordinate. So negative 10. So unlike the vertex, this won't be nice symmetric points, but let's see, 4 minus 3 is 1, 4 plus 1 is 5. So negative 10 is 5a. So a is negative 10 over 5. You divide by what's stuck to a, not by what's on the left side of the equal sign. And don't forget to actually write the equation. So
Finding A is only all the work. It's not the answer.
okay, remember that it doesn't have to be turned into either standard or vertex form. Factored form is a perfectly good form also.